In the previous video, we've looked at how to create new content asset types and also how to give users a way to create instances of those asset types with asset factories. In this video, let's go over how we can customize the look and feel of our new asset. And there are many different ways to change the appearance of our text asset types. We can change the display name. That's the little text that's shown in here in the center of these thumbnails. We can also change the color, red, yellow, green, blue, anything you want. You could even put a little thumbnail picture inside these icons. And there are several other options. And then another thing I want to show you is how the content browser action was created for reverse text. And all these things are implemented with yet another class called an asset type action. And those are plain old C++ classes that inherit the iAssetType actions interface. And that's really the base class for any kind of asset action that you want to support in the editor. And just like with factories, this interface just provides a set of virtual functions that you can override as needed. Let's take a look at the asset action that I wrote for text asset. If you have the plugin installed as part of your project, you can get there by navigating down to the text asset editor module. And inside the asset tools subfolder, there's a single class for the text asset actions that I wrote. And you see, in this case, I'm not actually inheriting from the interface class directly. Instead, I use some convenience helper class called fAssetTypeActionsBase, which is something that the engine provides, and it already has some logic built in that is commonly used. So it makes things a little easier to get started. And our class declaration, it contains a constructor, and then here we are overriding a number of virtual functions to perform different types of customizations of how our asset is going to be shown in the editor. So let's take a look at some of those in more detail. Here are three of the more simple ones. getName is what returns the name of the asset. And that's really, again, the text string that is shown inside the thumbnail right here. In this case, it's just text asset. There's also a function called getSupportedClass, which tells the editor that this asset action implementation is meant to be used for the uTextAsset class. You have to implement this, otherwise the editor won't know which type of asset to customize. And then here on the bottom, we return the color of the asset thumbnail, which in this case is it's just white. That's why we have a little white bar here on the bottom. All right, those are pretty straightforward. There's also a method called getCategories that you can override. And this one determines where in the content browser context menu your asset type shows up. So in this case, the text asset is listed under miscellaneous, but we could have also listed it in any of the other categories. And this line here is basically what makes it show up under miscellaneous. It's also possible to have the same type of asset show up in multiple categories simply by ORing the different types of enumerations that are available. Now, in theory, it's possible to add your own categories, but in practice, the categories are currently declared as an enumeration type, which unfortunately is limited to 31. And it's not very extensible, so I'm not even going to go into detail as to how to add your own categories. I recommend that you try to use one of the categories that's already present in the editor. Now, here are the two functions that I had to override in order to make available the context menu action for the text asset. And those two methods are getActions and hasActions. And as the name suggests, hasActions simply returns whether or not the passed in objects should display any type of context menu action that our asset action class provides. And then if this function returns true, the editor will actually call get actions, which will then allow our class to extend the context menu. And it does that by passing in two parameters. The first one is a collection of the objects that are being right-clicked. And remember, in the editor, you can not only right-click a single one and then execute an action, but you can also multi-select several assets and then right-click. And of course, then this action should be applied to all selected assets. That's why we're passing in a collection of objects. And note that in this case, we actually get a generic uObject pointer. So we don't know what types of assets are being passed in here. In fact, I could be selecting a material, a texture, and a text asset. And then in that case, I would have to make a determination whether or not I can provide any asset actions that are applicable to all of them, for example. The second parameter is a so-called menu builder. And that's a little helper class that allows us to add a new entry to this context menu that's being shown. And those entries for assets, they will be added at the very top under text asset actions. All right, so there are a couple more. There's actually like a little trick in here that I need to explain so you understand how this works. First of all, since we're inheriting from the asset type actions base class, we want to call the base handler as well. Currently, it doesn't implement any context menu actions, but maybe in the future it will. And since we're inheriting it, we should make a call and ensure that we're not accidentally dropping anything that should also be displayed in our context menu. And then the other, the next line here, the get typed weak object pointers, that's a little trick that I use to ensure that we're not holding on to object pointers that might go away. What do I mean by that? So uObjects, like I explained in the previous video, are actually garbage collected. And it means that if we are holding on to a raw C++ pointer to those kind of objects, it is possible that the garbage collector deletes and destroys those objects. So our pointer might actually be pointing to invalid memory, and then we would crash if we try to dereference that pointer. So instead, what I do is I request a collection of so-called weak object pointers. It means that this collection of raw uObject pointers will be converted into a collection of so-called weak pointers. And these weak pointers have the ability to automatically reset themselves when the garbage collector decides to destroy the referenced object. And you may wonder, why is that important? Well, you have to remember that when we right-click an asset and the context menu shows up, and then we click the action to execute it, there's actually quite a bit of time passing. So between the right-clicking, which is when this menu will be created, and the executing of this particular action, several seconds may pass. And it is in theory possible that within these several seconds, this asset gets removed by some other part of the editor. I can't think of a use case, but it is just something to be aware of. So taking a copy of the collection of raw pointers and converting it into a collection of weak pointers allows me to later check whether those weak pointers are still valid when I'm trying to perform the action on those objects. And oops. So these functions down here inside of add menu entry, they are containing the code that is performed for the actual action. Like for UI actions, there are usually two components. One function determines whether the action can be executed. If that function returns false, then the context menu option right here will be grayed out. So in this case, it's not grayed out, it's enabled. It means that this function returned true. And then the other component is the function that will be executed when we actually click on the action. And this particular code might look a little complicated, but it's really just a use of so-called lambdas, which are anonymous functions, or in other words, functions that don't have a name. So you can think of this as code that's being executed at a later time when the editor requests to run that code. And that's really all there is to it. So that's pretty much it for asset type actions. And to sum it up, the asset type actions allow you to modify the look and feel of your assets in the content browser. They're really easy to implement by just inheriting the iAssetTypeActions interface or some base class that implements its interface. You can customize things like the display name, the colors, the tooltips. And then the context menu themselves, they are extended via helper classes that are called menu builders. Now, if you remember from the previous video where we talked about asset factories and how those factories registered themselves automatically, that's actually not the case with asset type actions. Since those are not UObject derived, they cannot be discovered automatically by the editor. So you actually have to tell the editor that you wish to use or you wish to provide these actions by registering them by hand. And in the next video, we are going to see how exactly that is taking place.